So we're at about 9:37 now. So if you guys don't mind, I'll start. And so what I've got running right up here on the screen right now is some of the preliminaries for some of the coding that we're going to do. I'm going to jump back to the beginning of this deck and give you guys the introduction before we start moving into. Hopefully we'll get to 4 different code labs today. Let me move this back. Okay, I'm Sean Sullivan. I'm a co-chair in the SIG CLI. The other leadership for SIG CLI, Mache and Philip, are here. Some of the other SIG CLIers that I'm familiar with, Richard is here. I know Huawei is here, API Machinery. And so what I want to do is start off with what we're trying to do here. We're trying to kind of reinvigorate our SIG CLI community, and we're going to do that by giving some of the common patterns and common knowledge of kubectl development, and we're going to present that, and hopefully, if you're interested, this will be the first step in creating some more maintainers for this SIG. And so this is what I hope to accomplish today, is these 4 areas. So we're going to talk about, we're going to dive pretty deep into the code base for kube control. And the first part, we're going to talk about the basic structure of most kube control commands. There's, about 40 or so subcommands, and most of them all have the same structure. They use the Cobra Command encapsulation, that structure. They have options and flags, and the way that they're organized is all very similar. So once you've seen one command, you can see that structure is very similar to other commands. And we're going to actually today build an extra command and connect it into kube control. It's just called the foo command. And we're going to, after our first code lab, you'll be able to type kubectl foo -h and get the help for it, and kubectl foo options, and see the flags or the options for that extra command. And then the second part is actually where we start really getting into some of the deeper parts, which is the API machinery, and also how to read resource files off the local file system. And we're going to, at the end of that code lab, we'll add a resource helper and a resource builder, which are structures or encapsulations that kube control you're going to see in many different kube control commands. And we're going to actually, in the presentation, we're going to dig pretty deep into the REST API or what it looks like at the HTTP level, so that when you get to the higher levels of encapsulation, you kind of know what's going on underneath the covers. And then the third part, we're going to get to printing, and we'll add a printer to our command. And then at the final part, we're going to add a unit test for our command. So I know this is pretty ambitious, but let's see how far we can get in this. Okay, so let's dig right in. This is what a kube control command, subcommand, normally looks like. It has an options struct, and these option structs they're basically usually filled in with values from flags, and then kind of built up maybe from certain values of flags. And you usually have a function called new command foo, or whatever, new command delete, new command taint, that takes 2 parameters, a factory and some IO streams, and it returns a pointer to that particular Cobra command. Now, in that function, you'll create an instance of the options, and then you'll create that command. I've left out, just for space reasons, all of the usage variables that are part of this Cobra command. There's going to be like a short description of the command, some examples of the command, and some a long help for the command. And then once we get to the most important part, which is run, when you run your Cobra command, we almost always, in every single one of these Cobra subcommands, have 3 parts that we call. And they end up being methods on the options, so that they'll have access to the values of the options when they're being called. And so we have a complete, which will fill in all of the options. Then we have validate, which is going to validate the options, and then the actual running, which is run foo or run taint, run delete, etc. So underneath that is where we end up connecting flags that, so we define flags and we can connect them to this Cobra command. And so for this one, I've only shown one flag, and you can see that it's actually part of the Cobra command is this flag structure, and you could declare a particular variable, and right here where it says, it gives an address of a particular flag, that means that it's being copied into that particular flag. Whatever the value is. You have the name, the default, and then you have some usage. So many of these different commands are actually going to look very, very similar. They're all going to have this particular structure. And we're going to get to build one today. Okay, so this is just a couple, I just want to spend a minute talking about the Cobra command. Yeah, Mache? Yeah. So you want the code? Yep. That's a good point. Actually, I'll get to that right after this slide. So I just wanted to mention a couple things about the Cobra command. It's an encapsulation for all of the kube control subcommands. And it has really strong support for POSIX flags. It has intelligent help suggestions if you type in the wrong command. It has automatic help generation, so you don't actually even have to do anything to have -h show you help. It'll show you the examples that you put in the command. It'll show you some long description, etc. Yeah, and so that is obviously the link for Cobra command. Didn't want to spend too much time on that. Why don't I follow along with what Mache mentioned? So where are all of these commands? So So if you look at this structure at the bottom of this buffer, you'll see that all of the code, or almost all of kube control, is in 2 different places. We're moving kube control to what we call staging. There's still a little bit of the code left under package kube control, but if you look here, you'll see that this is basically the Kubernetes root, and then under staging source k8s.io. Actually, let's look at this one. Sorry, at the very top, package command, and you'll see that there's actually quite a few of the commands there. So let me see if I can get this to respond. Okay, this is a little... Okay, there we go. Okay. Okay, so this shows all of the different kubectl subcommands and where they're located. Under staging source, k8s.io, kubectl package command, and here's all the different commands. And this is the command that we're going to add, foo, but you can see that there's delete, apply, annotate, expose, customize, label. So this is where most of our commands are located. Okay, let me transition back to, these are the two parameters to almost all of these commands. You'll get a factory and you'll get a set of I/O streams. And the factory is mostly to build structures for talking to the API server, or maybe even for talking to the local file system to read YAML files off the file system, which is what's called the resource builder. So do you have a question, Lars? Did that? Okay. Okay, so we're going to dig into actually some code right now. And what we're going to do, so here's some of the preliminaries. As I was mentioning before, where the code is located is most of it in 3 locations. Staging source, k8s.io, kubectl, and then also there's some left in package kubectl. We're going to move that into staging as well. And we actually reuse a lot of the code that's under staging CLI runtime. And actually, I wrote that wrong. It's CLI-runtime. And so a lot of the code that is reused and reused into plugins has been refactored into CLI runtime. So the resource builder, the resource helper, I keep mentioning these. We'll dig into them shortly. Some of the common print flags and print options and printers, those are all under CLI runtime. So I'm gonna actually walk around now, and hopefully we'll be able to do Bazel builds. And if not, I've got some of the kubectl, some of the make commands down here. I think Bazel might be more successful for us if you have it installed and if you're used to that. After you've built kubectl, the binary is located with Bazel. This is the location for the binary. And here's a couple of the make commands. This is how you're going to make kubectl. So before we download this foo command, we're going to do a git clone, or we're going to add a repo and then actually update and actually download this. But before we do that, let's make sure that we all are on the same page with building kubectl. So does anybody want any help? So Richard, you already, okay, good. So is there anyone who's familiar with building? I don't have much experience building with Windows. Because I think we have at least one person who's building with Windows. Yeah, so I think there's like with Bazel. Yeah. So how we doing? Sorry?
I'm updating Go right now.
Okay. Yeah, the 112. Yeah, I just did that myself, just actually right before I came.
Because it broke so when I was trying to do some upstream Kubernetes, so I can
Okay. Okay.
Can we debug a command when it is actually working? Because I have done a small project on kubectl command. Like we have this kubectl like multiple plugins. Like we have unofficial kubectl commands. Like we have a library, right?
server version is going to tell you which particular cluster you're talking to. We haven't talked about setting up, talking to a cluster yet, but if you want to just look at the client, you can just do kube control version minus minus client. If you don't want to bother with the server. So you want this screen? So raise hands. Who's built kube control with data? Okay. Who hasn't built kube control? Yeah, who hasn't? Who needs help with building kube control data right now? Okay. Or run it. Who's made kube control and been able to run kube control version? So actually, this is another typo. I should have said make test what equals. I know that we're just use that package. So actually, this kubectl should say test. So I'm actually. So did you, so like I so yeah, we're supposed to be. So that's a test. So that's how you test the main or the most of the code. The test package so eventually we see a actually out of state. So even if you get out of the stage, have the foo command available. Can anyone let me know if you were able to get the first option to work to check out this particular language? Someone raise their hand when they're finally able to download it and check out that particular branch. So when it's finally downloaded and you've checked out the branch, try to do a basal build again of the command on control. Somebody can raise their hand when they finally build it. When you finally been able to download this and check out that branch, you're going to find that one of the commands is this extra foo command, and this is what we're going to fill in. Is this foo command. So let me actually, the first part of what we're going to do here is we're going to connect that foo command into all of the other commands, and the place we're going to do that is in command.go, which is in a slightly different location. If I can get this to respond. So how we doing? Okay, my guy isn't responding. get some of these things here. So you can see where the kubectl command.go is located. And so you can also see, once I move this bottom buffer out of the way, that this is actually where I've added, where we're going to add the up top under the basic commands. And once we've done that and compile that, then you should be able to type kubectl foo -h, and it will show you the flags for the basic flags.
That's failing as well.
Is it?
Yeah, try that one first. That was the faster one.
Okay, so we got one person.
Yeah,
Okay, so
yeah, I would say anyone that's doing a poll of everything, knock it off. Like that's totally not helping. Like let's just try doing the remote path.
yeah. Okay, so let's, if you guys don't mind, I apologize, it's bad call to try to clone this entire work with Kubernetes. Let's try the second option of setting up a remote and doing a fetch and then also then checking out the branch. So we've got this one person that's able to get that to work. So let's try the second option if that first option isn't working. There's even a third option that Richard here has done, which is if you just copy those files that are at the food files that are at that repo, that should have been my first option. I apologize for that problem. Yes. Yeah. So that's the one you want. That has more stuff. That's ours. So we're going to go to all these steps. This is Kubernetes control main. While you guys are working, you can notice that this is only a couple lines of code. So once you've built this, once we've connected the subcommand in, and we create the entire Kubernetes control Cobra command that has all the subcommands, then basically we lunge with the flags a little bit, and we start the logs. And the only thing, I mean, you can tell this is only, what, 13 lines of code, or 10 lines of code? All we're doing is we just call an execute on a command, and that's it for the main, for Kubernetes control. It's super simple. And so when you run this execute, it's going to eventually, excuse me, run your, parse the flags and call that run method that's in the Cobra command. Let's move on. So in the interest of time, since we're moving a little bit
underscore output.
So I'm actually going to move on to describing some of the API machinery stuff, just so that we can, for those of you who have already been able to compile the foo command, we're going to move on to the second part, which is kind of communicating with the API server, and also being able to read and decode YAML files off the file system. So this is going to be, there's going to be a lot of complexity here. I'm going to try to make this as simple as possible but still being able to get stuff done. So API machinery is a deep pool. There's a lot here, and I am necessarily going to not be able to get into all of the deep, some of the niches, and it's going to be missing some of the subtleties and the nuance, and I'm going to not even talk about particular parts altogether. But hopefully this is enough so that you could get an understanding of how to use the two structures that Kubernetes control uses most, which is the resource helper and the resource builder. Okay, so here's a layering, one layering of how we think about talking to the API server. So at its very lowest level, there's a REST protocol over HTTP, and I'm going to show some examples of what that looks like. And above that, we have encapsulations. The first layer of encapsulation is going to be a REST client. It's going to be a client that understands this REST protocol over HTTP. And then above that, there's going to be the structures that we normally use in Kubernetes control, which is the resource helper and the resource builder. Now, Maciej mentioned earlier, I'm talking about API machinery. Actually, it's slightly more nuanced than that, in that some of these structures are able to read and decode resource YAML off the file system. So not necessarily just the API server. So let's actually look at the lowest level first. What is this REST protocol? Well, if you do a kubectl get PO, if you've got some pods, you say kubectl get PO minus V equals 8, 9, or 10, you're actually going to see what's happening at this lowest level, at this REST level. And what you could see is that we have different methods like HTTP methods like get, post, patch, and then you have a particular URL that maps to resources at the API server. So this here is actually asking for all the pods. This is a kubectl get PO, or get pods. And this is what it maps to. And there's particular request headers, and there's a user agent. And if you do this, these particular commands you can actually see at this level. Right? This is the lowest level of talking to the API server. So this is the response. So we get some response headers, and the important part is, for this part, it's a table, but it can also be a pod, right? It's actually a JSON blob in the response body. And so what we're going to talk about, and I think what a lot of these classes in the API machinery are built to do, is actually the main object is to how do we get this blob into a strongly typed Go object, Go struct for instance, a pod. This is a table, but for that particular type, there's going to be a kind, a version, a group version kind, and I'm going to talk about that in a second. So as I mentioned, a lot of this machinery is this particular transformation of this response body into this Golang struct. Or the other way around. If we have a Golang struct of a pod and we're creating it, and that's going to be a post at the REST level, then it's going to have to encode this Golang struct as this JSON blob in the body. Okay, so as I mentioned before, there's a significant amount of complexity here. And again, this is simplifying things dramatically. But I want to actually go over a few of the classes that are going to peek out from underneath these lower levels that you're going to have to understand in order to productively use kubectl. So the first is this group version kind. Now, group version kind it's just, I put some examples there like apps v1 deployment or core v1 pod. It ends up being, if you look at the code, it ends up being just 3 strings. A group, a version, v1 or v1 alpha 1, v1 beta 1, and then the kind, which is pod, deployment, component status. And then you'll see what's a GVR. So I bring this up only because to keep you from getting too confused. It turns out that they're pretty much the same. That it's also 3 strings, and it also basically describes the same concept. There might be slight nuances. I think that the GVR was created in order to be able to have different endpoints for the same kind, or maybe the other way around. Like one kind can have multiple endpoints. I forget, but for all intents and purposes, a GVR is equal to a GVK. So now we're going to talk about a REST mapping. You're going to see REST mappings in the code. A REST mapping is just a GVR and or a GVK and its namespace scope. It could be cluster scoped. In other words, it doesn't have a namespace. It's scoped to the entire cluster. Or it can be scoped to a particular namespace. That's all that scope means. So when I first read this, to be honest, I was slightly confused for a little while until finally clicked that this REST mapping is a GVK and some information on whether or not it's in a namespace. That's it. So then we're going to move on to a scheme. So we're going to need to use a scheme in order to be able to decode in kubectl. And a scheme is actually just telling you which GVKs we understand. It's literally just a list of a bunch of group versions. So you had a question? So yeah, correct. So different versions of Kube control, like right now we're building it at 117 is coming out. They're going to have different understandings of what the versions of are the most current versions of these kinds, of these group version kinds. So we've recently just changed, like extensions v1 beta 1 used to be what deploy the most recent version of a deployment. Yeah, it was a deployment. And is that right? And we changed it to apps v1, right? That happened just recently. So so how can we translate it? So give me a second here. That's actually slightly deeper than I wanted to go right now, but that's a good question. Well, let me finish out here with the glossary, and then hopefully I'll at least touch on that particular question. So from the scheme, which tells you, all the group versions that this particular Kube control understands, we have this concept of a codec, and you'll also see serializer. Now, literally, codec is serializer is a codec. It's type diffed as a codec. And a codec is just the encoders and decoders that understand for all the GVKs how to encode and decode from these JSON bytes into these Golang structs. And as you mentioned, they're different. Each version of Kube control is going to have a different understanding of what we call the state of the art, or what the current versions of the GVKs are, and those are updated periodically. They go from alpha APIs to beta APIs to GA. Okay. So above the REST protocol, we have this a REST client that's in client Go. And here's basically all of the methods that it understands. And you could tell that most of these correspond to a HTTP method. So there's a get, there's a patch, there's a put, delete, and then there's a couple of extras. So just so we don't get too confused, this is a narrowing of that REST client interface that we use. And this is, I've shown up top where this interface exists. So your general client Go has an interface, and in Kube control, we've narrowed it to be just those particular REST methods. So you're going to see the REST client in a lot of different places. That's what this is. It knows how to spit out that low level, the HTTP method, and to generate the URL in order to talk to the API server to do the CRUD operations on the API server. Okay, so at the highest level, the level that we're dealing with in Kube control, there's two structures that we deal with the most. There's a resource builder and a resource helper. And these are also under the CLI runtime, staging CLI runtime hierarchy. So the builder is what we use to retrieve a resource, whether it's on the file system, and this was a good point that Maciej made, whether it's on the file system or on the API server. And it understands how to decode it into these Golang structs. The builder does. The helper is more, it has more functionality in that it actually can do, you can create and patch on the API server. It's not just retrieving. But it's basically a wrapper around the REST client. It makes the REST client easier to use. Okay, so now what we're going to do, for those of you who've been able to connect your foo command in, we're going to actually add a resource builder and a resource helper. We're going to read in, once you've added this builder, you should be able to read in a file, a YAML file, and it should be decoded into a struct. Like if you're reading in a pod, it should actually decode it into a pod. It's only going to give it to you as a runtime object, which is the highest. It's a very thin interface over every single type of object. Let me see, and we're going to actually add a resource helper. Okay, let me go to some of the code here. Okay, so in the interest of time, I've actually, if you check out the next branch, if you were able to finally get that code, if you kubecon-cs-workshop-2, you'll see that this is how we've added a builder and lower down a helper. As I mentioned, in the interest of time, I'm just going to move through this. I'm going to show you how we've already done this, because I don't think we're going to have time. So this is what the resource builder looks like. Now, I mentioned before, when we're talking about the glossary, the scheme. So we're using this builder, this resource builder, with the scheme. There's kubectl has its own scheme, which GBKs that it understands, and you could tell. I think your question earlier was, what's the priority of the particular? So there's actually methods that will automatically prioritize these groups and versions for you. So for instance, the apps v1 is higher priority now than extensions v1 beta 1 was recently. So that it'll find the apps1 v1 deployment before it finds the extensions v1 beta 1 deployment. Did that answer your question? Sorry? You're actually going to find it if you looked under the kubectl scheme, the prioritized versions all groups. It's going to have that prioritization for you. So once we call do with this build, so the other more important thing in this particular example is the file name param. So I've added an option for the file name options, and I'll show that up top. And when we call do, it actually will return a result that we're going to iterate through by visiting. So you're going to see this quite often in a lot of the kubectl code. So let's look. So this is what happens with the result from that builder. So you're going to iterate. This is a very, very common pattern. You're going to iterate through, and you're going to receive or visit on infos. So this info has an object in it, which is the actual object that got decoded. And it's as I mentioned before, it's a runtime object. And so what I've done is I got the resource mapping, which is very close to a REST mapping. And from that, and using the factory, I was able to create a client, a REST client, And with the REST client, I was able to create the helper. And from that, I was able to, so if you run this code, it actually will read the YAML file into its object, and it'll create it on the API server. So you'll see that I added some options so that we could read in this file name. So this resource.filename options is a standard way to read a file, a directory, or I'm not going to get into it, a customized build of the resources into this file name options structure. So now I'm going to open it up to questions. So I think we got about 20 minutes left. So does anybody want to try to add that builder? What? So there's 2 more sections after this, and we only have 20 minutes. So I might just present on how we do printing, and actually get into a little bit of unit testing. So kind of give up a little bit on the coding part. I apologize for, I think it was way too optimistic on what we were able to get done today. But hopefully, by presenting this information, somewhere else, later on, we'd be able to actually fill in the foo subcommand, the subcommand that we were downloading, and actually fill in the unit test. So let's just go on to printing. Okay, so this is a common pattern throughout kubectl, which is from flags, you're going to build important structures. And so there's actually a standard set of print flags for kubectl under generic CLI runtime. Again, I keep going back to that. And from those flags, we're going to build the printer, the ability to print a resource. And then that resource printer, that interface only has one method, which is printObj. So this is how kind of we've layered how printing works. So this is extremely simplified, just so that we could get a high-level understanding of how printing works within kubectl. And so I'll actually show how that works. So we've actually added some print flags to our options struct. And these are standard print flags. So why do we do that? So within kubectl, you could do a kubectl get pod -o name, -o YAML, -o JSON. There's many different standard ways that you can print. And this structure automatically gives you all of that. All of the standard ways to print within kubectl are given to you with the standard CLI options print flags. In fact, why don't let's see if I could get into that. So here's the print flags. You can see there's JSON and YAML print flags, the name print flags. There's a template printer. There's different outputs. So here, this is what the print flags actually looks like. This is what it gives you off the bat. So once you've declared that in your options, then you're going to actually create an instance of that. And this particular created is the operation that happens. And so that can get printed under certain circumstances. So because in this foo command, I've created, I'm sending one of these resources to the API server to store it, I wanted to say it got created. So this is the option when you pass in those print flags. Let's see. Looks like a... And it's the default output I want is the -o name, meaning it's going to print pod slash the name, if it's a pod that I'm printing, pod slash the name of the pod. So if you ever see that if you do a kube control, get pod, the name of the pod, -o name, it's just going to print the name of the pod and the type, and the kind, actually, from the GVK. That's one of the ways to print under kube control. So I said that that's going to be my default printing. And then up here, I'm actually going to, from those flags, you could see I create a printer. It's just toPrinter. And then after I've created this object by sending it to the API server, I just call printObj, sending it to one of the I/O streams, the standard out, usually standard out stream, and I'm printing the object. And so let's see if we, let's see. So here's my foo. If I do, what is that? Test. So because my default printer was the name printer, it prints it out in the name format, kind name. But if you wanted to do -o YAML, right, this is a very common way of doing this. If I can get this to actually. It's going to print it out. Oh, whoops. I don't know why that happened. Oh, because this lag is quite a hassle. So it didn't say anything because it didn't create it, because it's already there. So let me delete it. Okay, sorry about the lag, but once I'm going to rerun this -o YAML command, it'll print it out in the YAML format. Actually, I have to actually run the foo one more time. No, actually, I don't. Yeah, so there we go. So it printed it out in the YAML format. That was a little bit long to do that. So that's printing. And so I think, let's see how much time we have left. We got 10 minutes. So now what I'm going to do is actually show you a few examples of how to write unit tests for kube control commands. And the reason that I think that this is important to see examples is because it's actually quite awkward the way that we mock out communicating with the API server. We actually go all the way down to the HTTP layer, and we mock out using a test factory what the responses are from, given a particular HTTP GET or POST or whatever the REST request is. We mock out what the return is. And so I'm going to show us some examples of what our unit testing looks like, just so you could get used to this kind of relatively awkward way of mocking out stuff. So we know that for each one of these commands, we have two parameters. We have a factory, and we have these I/O streams. And so in order to unit test our command, we kind of have to fake out those two things. And I'm going to show you some examples of how we fake that out. And again, with this test factory, many times what you're going to see is that we dig all the way down to the HTTP layer to mock out what the communication looks like to the API server, which is, as I mentioned before, it's quite, to be honest, it's a little bit awkward. But let me show you some examples so that when you do see some unit tests for kube control, this is what it's going to look like. So. Okay, so this is a test where we're creating a test factory, and we have to actually add our own codec. And so this is the kind of awkward part, which is we're creating a fake REST client in our factory, which is hard coding for this particular HTTP request. We hard code or mock out an HTTP response. And you can see we fill in the body. So for instance, we would fill in the body, the HTTP response, with using this codec and one of these items that we were able to, where is the items? Oh, it's the RC, which is the test data, which is a particular, it gives you a bunch of different resources to test that, hard code like a pod or a deployment or a service, and you could grab one of those items and actually throw it directly into the HTTP response of the body. So this is kind of the super awkward part. And so the rest of it is actually somewhat clean in that you create your command, and then you put into it this test factory that has the mocked out interaction with the API server, as well as some test streams, and then you just set up the flags you want, and you call execute. And then you're going to look at one of the buffers that's associated with one of the streams, and you're going to see, well, did it print out what I thought it was going to print out? Or usually what you're looking for is the buffer from one of the streams to see what you think happened actually happened. Okay, so I think that we're coming up to about 5 minutes before the end of this session. I'm going to actually plug our SIG CLI session that we're having on Thursday, right? So as part of what we described, what we wanted to do initially for this particular presentation, I talked about digging into the dirty details of kube control development, but also we eventually want to get to what is our vision, right? What are we going to use this information for, right? And this is where, this is this invitation to all of you to join the SIG CLI and to join in our vision of what we're going to build. And we're not going to get to, obviously, that vision here. We just don't have enough time. We didn't even have enough time to cover these 4 parts of kube control development. But in that SIG CLI session, we hope to inspire you to talk about what we hope to accomplish with kube control. And again, we'd love to hear your input, but we're going to try to get us all onto the same page so that we're all marching in the same direction on how we see kube control going forward and what we want to work on and what we want you guys to join us to work on with us. Okay, I'm going to actually, I think that this next session is got 5 more minutes? Okay. Well, actually, I didn't have a whole lot more than that. Actually, we'll look at, if you want to, we'll look at one more example of what these unit tests look like, just so that, again, you get used to this kind of kube control way of doing unit testing, and so you can make sense of this. Let's look at the taint test. Okay, so here's another example of the unit testing and how we're hard coding the HTTP response. We're creating the test factory. We're creating the test I/O streams, and then we're actually sending those into the command and then executing it and checking out the response. Okay, yeah, you got a question? So the mocking for the control plane is actually done all the way at the low-level HTTP level. That's just the way, we're actually mocking out what the response from the API server looks like at the HTTP level. So that's what that fake client was, the fake REST client. It was saying that, this is the object that's being returned. These are the headers in response to this particular HTTP request. Yep. Yes. So the integration test for kube control is it's make test-cmd, and it's under. Let me see if I can find it. So I might not be able to find it in the time that we've got, but I'll come over and talk to you about it. But that actually there is a very significant integration test that's only available under make. Okay, so I'm gonna stop it there, and but I'm gonna be just right outside if you guys want to talk to me, and I'd really love to talk to any of you guys who are interested in the more kubectl development. Please just meet me outside and let's have a few let's talk for a few minutes. Love to hear your experiences and what you're looking for. So thanks.